Right. So as I said, we talked about reflection and refraction, and the main law is what? The main law is angle of incidence equal to angle of reflection. So anytime you see reflection, those two angles equal. Then we talked about hold on. Huh? Yeah, that one side is staying there. Right. So as I said, we talked about reflection and refraction, and the main law is what? The main law is angle of incidence equal to angle of right. Then we talked about refraction. You all seen that yet? We talked about refraction, the bending of a ray as it goes from one medium to the next. And we talked about whose law is that again? Steiner. Snell's law, right? Snell's law could also be written in terms of speed and wavelength. Okay, it gives you an idea of how much the wave is going to carry. All right. I gave you the notation. What those things mean? Frequency doesn't stay the same, right? What does this diagram show here in blue? What does the blue show you? You gotta remember what the blue ray shows you? Critical angle. The blue ray shows the critical angle. When the angle of incidence gives you an angular refraction of 90. What does the red ray show you? Total internal reflection. Very good. What are the two conditions? The two conditions for total internal reflection are angle of incidence equals to greater than critical angle, and its second is in the denser medium, right? Two simple laws based on. All right, good. So now we're going to take a look at past people. I think I did one small past paper last day. Right? Two. Okay. Let's continue. Oh, it's a good one. It's a good one that we did do the experiment. I remember that. Look at this here. This. Side is complete. Right now it's here. Hold on. So wait, this one too? I did like that. Hold on, I give it 1 second. So I can flip it over again. What are you looking at? Same thing? Just give me 1 second there. Let me just get your original back, right? Alright, one of these here. Let's see if I can find back the original, right? I don't know what to do there. Don't know what to do. Alright. Like again, let's put the work. What happened if some of these are? Alright, what about this one? You all seen this one?
Yes.
Alright. And not the last one, right? I'll find back the original for that just now. Alright, so watch this here. So in this question, they gave you, in this question here will be the last part just now. They said that the prism ABC shown in figure 1 can be employed as a reflector from a laser. Determine the relationship between OA and OB, right? There's a little bit of maths as well, right? So first thing first, look at the ray. The ray starts at W, it's going through the surface AC and meets where? At X, right? What happened at the surface X? What happened at the surface X? It bent at 90
It got
degrees.
reflected.
Very good. Who said that?
The Nico.
The Nico, very good. So if you look at the ray, it got reflected. So it means that inside here underwent total internal reflection, right? So good. So we need to find a relationship between OA and OB. The physics question goal. That was the max part of it. What will that angle be on here? How are they related? Sorry. How are they related? How are they related? How is OA and OB related? I think you have a tell now. Yeah, anybody? Nobody? Anybody online? How y'all think OA and OB related? I can only give you a few hints. Here is 90. Here is 90. Here is 90. Yeah? That's what I give you. Yeah? Equal? One could say equal. Right? So either equal, more than, sorry, less than or more than. One of them. Anybody else say equal? That's the only answer, so go with it. Go with equal. So if this whole thing here is 90, right? If this whole thing here is 90 and it underwent reflection, how much is here and here? How much is there and there? 45, right? Yes, Kieran? Here is 45 and here is 45, correct? So how much is here? How much is there? Pick up by using choice. So if here is 90, then here is 45 and here is 45, right? So it means that this angle here is in this 45 as well. Because remember, here is 90. And Adele? So if here is 45, Adele, here must also be 45. Okay? And if here is 90, how much is here? 45. So it's always a max. So you recognize that OA is 45 and OB is 45. So it means that they are both equal. Right? Theta A and theta B are equal. Right? Right, Adam? Theta A and theta B are equal. Oh, but what yeah equal, I don't know. I can't theta. I lost the sorry for that. Get the diagram. Get the diagram. Right? Find the condition. You're done? No, sorry. Right, while you're waiting, for those who wait in the Jalen, find the condition theta B must satisfy in order that total internal reflection of EV occurs. What's the condition? You want total internal reflection to happen there. What's the condition that theta B would have satisfied? The back of the condition. What causes total internal reflection? So theta B must be greater than the critical angle. That's it. That's all. That wasn't so hard, Malachi. You don't figure that out.
So you go add us in the group today?
Yeah, no. I started already.
Yeah, so we missing notes, so we had to get it.
Yeah, you're getting it now. All right, next one. Try this one. Take a look at the diagram, right? If you look at the diagram, any total internal reflection, look at the diagram. Any total internal reflection happening? You're not looking like that, right? What happening? As it moves from air to medium, one to medium, to back to air. Just refraction. So since just refraction happening, which formula might be using? Snell's law, right? That's okay? Sure. So write down Snell's law, write down the three Gromit speed, wavelength, and angle. And still can work out this one. Right, in the meantime, I'm gonna start to ask people. Right, those who online, if I did ideas here, message me fast there. Right, who gets not in the group again?
So I message you sometime enough. I think it must be. I think this was my number.
Well, sir, I do have your number.
7230529. Go, plan two. Was Ravi or and was. I have tried this here. Didn't equal. Equal online.
Yes, sir.
Okay, so the first part is what? They give you the angle of incidence at 60, they want you to find all the angles. Theta 1, theta 2, theta 3, theta 4, theta 5. All. Right, who else? Either showing ideal networks.
Yes, sir. Thanks, sir.
Right, who else? Okay, this is my assignment, do class next week. Okay, should hurry up, hurry up. Anybody else have a question? Alright, so good, so we should be done with this, right? Right, everybody in groups, right? So let's start about sharing notes, right? Alright, nice. So let's correct this. So if you take a look at the diagram, right? The diagram shows at different points. It shows incidence here, refraction here. That's from A to medium 1. Then What would be theta 1 and theta 2? A little more skills. It'll be the same thing, remember? Parallel line, same chord, angle here equal. Then, if we figure out theta 2, we can figure out theta 2 and try to figure out theta 3 using what? Snell's law again, right? If we figure out theta 3 phase, phase, what will be theta 4 phase? If we figure out theta 3, what will be theta 4? Same thing. And then theta 5 is what? As what? We gotta figure out theta 5. All right, so that might be the hardest, right? What they gave us? They gave us the refractive index A to medium 1. So that's right here. So it means that we can use n is equal to what? What's the formula, Ravi? N is equal to what? Sine I over. I'm trying to make R the subject of the formula, right? So I'll rearrange it for you one time. For those who can't rearrange, good, learn this formula, right? R is equal to sine inverse sine I over n. Any answers online for those who did this? Right? If it didn't do it, okay. When I move here, you can't come back in that door. Okay, go on. All right, work it out fast and we're going to get theta 1. Theta 1 is equal to sine inverse sine 60 over. They give me the refractive index up here, 1.2. Right, you get brackets properly and I'll give you an error, right? Quinn got 46.2. Quinn got theta 1 to be 46.2. Anybody else got that?
Yeah, I got it.
Come on, Malaka, guys, check it, please. Sorry, I got it.
Right, yeah.
Check it right. Yeah, and what is theta 2, Ravi? What is theta 2, Ravi? Ravi, I just the lowest theta 2.
Yes, you have it on that, but actually.
Which is what? Correct? Yeah, what is the 2, Ravi? Ravi, that's basic maths there. Same thing, Ravi, the angle is equal.
Yes, sir, I said.
Why the angle is equal?
Because. Yes.
Right? What's the name of the rule again, Olia? Y equal alternate angles. Okay. Right. Theta 3. What's the refractive index from medium 1 to medium 2, Ricardo? Ricardo, what's the refractive index from medium 1 to medium 2? Hello, Ricardo. Huh? No, let me give it some up there. Refractive index of medium 1 to medium 2 is 1.25. Okay? Didn't see that? So how are we going to find theta 3? What's the formula we use in what is? Cheryl, what's the formula we're going to use to find theta 3? Cheryl, the angular refraction. what we're going to do. Well, I think so. Same thing, yes, same Snell's law, right? Same Snell's law. Sine inverse sine 46.2 over 1.25. Why did I use 46.2 feet? That's what I gave you for. All right. Yeah, that's a new argument. Fix it, I'm going to get China, you working it out? Caleb, I'm getting the answers from your Caleb. Jaya, very good, Jaya. I like to see you there, Jaya. I like to see you there. Right, Jaya. You got up? Jaya got 35.3 and Karina got 35.3. You got up? Next one. Let's pronounce her name again. Kabina. Kabina. Yes, Kabina. You can't hide Kabina. I know your name now. Theta 4, Kabina. What is theta 4? Same thing. It's an easy thing. Easy thing. Jacob, one for you now. Theta 5. Same thing as what? Theta 5 is the same as? What I mean the question after the angle. Same thing as which one? Theta 5 is the same as what? Theta 4, but and it's underwent refraction, or to be the same. Theta 5 is the same as something, but not theta 4. As 60, correct? Yes. Right? Write it down. Incident rate. Write it down. The incident rate is always the same as the emergent rate. Ricardo, if you don't mind, you can write it down, please. It was not too much trouble. Incident rate is equal to the emergent rate. So theta 5 is always 6. Sorry? All right, and you have one last thing. What is the velocity of light in medium 1? What is the velocity of light in medium 1? Try that, please.
No problem, yeah. I never last year.
All right, so how are we going to find this one here? How are we going to find the speed of light? Yeah? Which formula has speed of light in it? Refractive index is what? Speed in medium 1 over speed in medium 2. And what was the refractive index from A to medium 1 again? Huh? 1.2. So 1.2. What was medium 1? What was medium 1, Kiran? Medium 1 in this case was A, right? Remember, it came from the air. So it came from the air, 3 by 10 to the 8, and then we tried to find its speed in next one here. Cross multiply, and you'll get 3 by 10 to the 8 all over 1.2. Before you work it out, should it be faster or slower? Should it be faster or slower in medium 1? It should be slower, right? So your answer should be slower here. Copy it down. Oh, tell me what you got, please. Tell me what you got there. What you all got? What you got, Neera? Calculator. Very good. Just a minute, just standard formula. How much? 2.1? Like 10 to the 2.8 by 10 to the 2.5.
2.9 is 2.5. Yes. That's what I'm saying.
2.5%.
Right. Well, that's good.
Right, 2.5 by 10 to the 8. Yeah.
Yeah.
All right, let's go again. Let's go again. Huh? All right, not the best pick, but let's take a look at it. Take a little read. Just do my favor. There's a value underneath here you need to write it down now. Refractive index of water. 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 Oh my God. We realize that. Right? I'm going back up, right? Yeah? Just write the value. All right. Go ahead, Robbie.
Yes, good.
Hey, Steven, what's it on here now?
So there's nothing that you go.
Oh, yeah, look at it, it's Malachi, hurry up, please. We have more to do.
You're serious?
Huh? Right, they wanted to find critical angle, yes. That's all, right? Find a critical angle. Huh? Sorry, yeah. Yeah, they were saying, now they're going back. I don't know where they're going. Go ahead and get me marked.
Yes.
Oh, yeah. Oh, yeah. We'll go to the angle, the back of the pole, that's what we do. Oh, yeah. So how do we find critical angle, Ravi? How do we find critical angle? Ravi, find the formula. We just went through those formulas.
And everyone
Critical angle.
Yes.
Oh,
You know,
no, it's one.
这伪装那个知道，这位刘是。
Oh, yeah, just go back to full. I'll check back with my door. Alright.
You don't take it. Yeah.
One sign,
Yeah, I told you.
sign verse what? Come Ravi, one little formula there. Maria, how much you got, Maria? Ravi. 1 over is not R, N.
Yes, that last. Say.
So it's sign in verse 1 over 4 and 3, right?
Yes.
And the critical angle is how much? Maria got 32 and Maria got 48.6. Check it back in Maria. Sine inverse 1 over 4 and 3, which is what? What's 1 over 4 and 3?
48.6. Yeah,
48.6. Okay. Check it back in Maria. Anybody online got 48.6 again?
Yeah.
Yeah, Jaya. Okay, nice. So it's sine inverse 1 over 4 and 3. Okay, thank you. Good job, Quinn. And last part. What happens to the ray if the angle of incidence is 68 degrees? Right here, I'm going to ask somebody to explain. What happens to the ray if the angle of incidence is 68 degrees? And that's going back here, right? So the question says that I is 68 degrees. What will happen? Write it down and give the reason why. Shannon, are you there still, Shannon? So write down in your own words what will happen if the angle of incidence is 68. You have to say why it, don't just write what will happen. Say why you think that will happen. 2 reasons why. 2 reasons why you think that will happen. Check out in the Thank you for it. Yeah, Chilan. So Chilan, the angle is more than 68. What will happen? What will happen if since the angle is more than 68? I is more than 60. Right, so 68 is more than 48.6 and one more reason why. Which is more dense, the water or the air? The water, right? So the answer is the total internal reflection will occur. The answer is total internal reflection will occur because the angle of incidence is more than the critical angle and the reason denser medium. I'm sorry, can you go up? Can you give it up? Let's go again. Yeah, more. We have more to do. All right, this one is not the best photo, right? But what is here? This here is the first question that we were trying to do at the beginning of the class, right? If you look here, Malachi, come on, sit down. Come on, sit down here. Phone is hot here. Come on. Stay quiet, please. Right. If you look here, right? What you will have here is a ray entering a glass block, right? You all made this experiment in the lab, right? And so you have a glass block, and on that glass block, you have a ray coming in. That ray will undergo refraction, right? If you look at the solid line there, right? This solid angle of incidence there. If that block was not there, then the ray will go along that straight line. That's okay. But because the block caused refraction, right? The ray came out lower down. So you see that length of that angle there, right? Very good, Jamian. Right? Not now in the class, right? Because of the glass block causing the refraction, there is something called deviation there. Okay? There's something called deviation. So I want you to try to label. Let's see if we can label all of it, right? You can head up glass block experiment. Right? It's the glass block experiment to find refractive index. Right? The glass block experiment to find refractive index. Right? So let's see if we can label some of these things, right? That ray A. What do you call the ray A? A is the what? A, capital A. Capital A is the what? Incident ray. What's the upthrust? Oh, because the upthrust there. A is the angle of, sorry, small a is the angle of incidence. All right, then. Capital T is the what? Capital T is the what? Capital D. A refracted ray. Capital D is the refracted ray. What is common D? Angle of small d here. So see that? Small d. That's the angle of what? The angle of refraction, right? Capital D is the refracted ray. And T is the what? Everybody will come out?
I think so.
So did you come out with? The emergent rate, very good. The emergent rate. And X is what? X is what? And that's the go there. X. Yeah. X is the just do your axis. Distance between the, it's called deviation. Let's call it deviation. X is the deviation. And now explain deviation. Somebody can explain what deviation for him there? Right, the deviation is distance between the path the ray would normally take. Deviation is the distance between the paths the ray normally takes and the emergent ray. So the paths the ray normally takes and the emergent ray. All right, so if you do the glass block experiment, those are the things that you will observe in the glass block experiment. And all you really need is A and B, right? The angle of incidence and the angular diffraction. The angular diffraction. All right, a sharing in the group manual or from somebody that does not find out. Right? A manual with notes on some of the things that you've been doing all the time, right? So for those who would have missed out, you could use some of them. I can load now, right? Right. So quickly, some that we have to talk about. Optical fiber, if you look there, the optical fiber is a device that uses total internal reflection. So that's the way we get the light rays dependent. You'll see that? Watch the light ray as it travels out of the watch the light ray as it travels out of the optical fiber. Every time it hits the surface, what happens? Total internal reflection, right? So because of total internal reflection, it's able to keep it in there. Here, we have a ray that underwent what? What happened to the ray here? It underwent total internal reflection twice, right? And the ray traveled through 180 degrees. Okay, I just want to show you that back quickly on board here. Right, just one last thing and we're done. Remember next week, one likely no class, right? Any changes out there, you know. It'll be online though, right? Yeah. It won't be face to face for sure. Online, you'll see the whiteboard.
No, sir.
So easy, huh?
Hold on, eh? How about now?
Yes, so easy enough.
Yeah, we see no.
Oh, 1 second. I'm trying to get it back. All right, but you all seen it, right? Anyway, so what's your step? Right, just one thing I want to show you here. If we have this triangular prism, we need to be able to explain what happens as it travels through here. All right, so watch it here. If you look at this ray, when the ray, you're seeing, okay, see it? When the ray hits the surface, right? Where is the normal? Where is the normal? Surface here, so the normal right here, right? So technically, the ray traveling along the normal, right, Nalini? Right? The ray traveling along the normal. So what does that mean? It means that nothing will happen to the ray. It will continue along that path. We should remember that the critical angle for glass is around 42 degrees. All right. When the ray hits this surface here, the angle here is 45. Right? So what do you think will happen? 45 is more than this, right? Glass is more dense than air. So what will happen? Total internal reflection. So here will also be 45. Okay? And then when the ray hits here, it travels along the normal again. So what will happen to it? It will come straight out. Okay? So in short, the ray travels through 90 degrees. So by using a triangular prism, right? By using a triangular prism, we could bend the ray 90 degrees, or like the one I showed you in the notes earlier, we can bend the ray 180 degrees. Are you okay with that? So draw it in your book, and I wanted to explain it for homework. Don't take a picture. Draw it in your book, and for homework, explain it. All right. Next day, we're going to continue with the last two principles: diffraction and interference. Okay. Copy it down, and I want you to explain it for me for homework. Right? Everything I just said, right? Undeviated, total internal, undeviated, right? So for homework.